could end up with a moment diagram, you know, of something like this. Right, there's our typical moment diagram. And again, we calculated some specific values out here at the end to account for a little bit of negative moment, even though our S-frame values might not necessarily consider that. Right, so when we went through and did our slab, we were focusing on bar spacing. Well, when we're looking at our beams, we've now got a finite space to put in here. And this is where we go and figure out our AS required and figure out how many bars. And I put in equal multiples of, full bars. Right, so if I get like 3.2 bars, I'm going to round up to 4 bars on the bottom. Right. Now we still have all of our spacing checks and what have you go through on here. But this would apply to that specific value. Well, out here, the moment resistance is less. So I wouldn't necessarily need all 4 bars in that location. I could get away by using 2 bars, right? And it's one thing to go through the calculation and say, I need 4 bars there, and 2 bars there, and 5 bars there, and 3 bars there, and so on. But what we want to do with our beams is also come up with a pattern of reinforcing which is compatible across the various areas. So we're going to have, at a minimum, 2 bars in each corner, so a bar in each corner, 2 bars top, 2 bars bottom, that run continuous over the entire length. Right? This allows us to put in our stirrups, assuming that we have stirrups in our beam. And we now have enough to be able to build that steel cage. So at a minimum, we're going to have a bar in each corner to do that. So what I'm going to be looking at is saying, okay, if I'm starting with my minimum of a bar in each corner, then where does that fit with my moment diagram? What kind of moment resistance do I get with just those 2 bars? And then I'm looking at areas where I could put in additional bars. And I might just add 1 additional bar, I might add 2 additional bars, and they may vary. I may end up with like 2 rows of reinforcing here and only 1 row of reinforcing there. Right, so we might have a configuration as I take a look at this and say that, okay, at this section right here, maybe our cross section, it looks like this. But over here, our cross section is going to look just like that. And that would be for our negative moment. Right, so again, we'll have 2 bars on the top. Maybe out here, I need 4 bars across the top. Right. So what works really well for this kind of configuration is something where I've got an odd number of bars in my largest configuration, so like 7 bars across the bottom, and then I can take out every other bar, and I'm left with 4 bars, right? So 7 and 4, right? And so we end up with like a pattern. 1, 2, 3, 4, 5, 6, 7, and I go out and I would get rid of every other bar working out in the corners, so get rid of those ones. Right, so you can't have a pattern where I've got 4 bars going to 8 bars without adjusting the spacing, without getting kind of cramped, unless I go to a pattern where I've got 1 row of reinforcing, 2 rows of reinforcing. Right, that second row of reinforcing is easy to add in there. Right, so there I can have 4 on the bottom and then add 4 and get a total of 8. But if I've got it all on 1 row, right, it's an odd number and then an even number. Right, so an odd number in the highest configuration and an even number in the lower configuration. And that kind of pattern works out reasonably well. Now, once you go through and you figure out at all the various points what my reinforcing is going to look like, what you can then end up generating is a moment resistance curve. So here we've got our moment diagram. This is, technically, we'd have a moment envelope with all the various curves. And what we'd be looking at is, as I go through my various configurations, plotting up what that moment resistance looks like. So, right at my moments of high region, I've got a particular curve that I'm looking at over here. Right, then when I get down to the lower region, I've got a curve that comes out like that. Right, the same thing is going to come out over on this side and so on. And the transition from that moment resistance, from the lower moment resistance up to the higher one, occurs over a development length. Right, so this would be a development length and so on. Right, and I would also have a corresponding negative moment resistance curve. At some point we would have some minimum value that would be here, just 2 bars continuing across there. And what we want to do is check to make sure that our moment envelope lies fully within this moment resistance curve. Because what can sometimes happen when you take a look at different load combinations is I could have a load combination that did, something like that, and just in this little area it kind of pops out. So if you just check just your maximum values only based on a particular load case or load combination, you might miss that on a load combination which does not cause a maximum effect, you do happen to have a scenario where the moment is shifted to one side a little bit, or at a different angle or something that causes you to be outside of that moment resistance curve. Right? So it is a process of going through and coming up with different patterns of reinforcing across the beam, come up with those patterns as to what they're going to look like, figure out what the moment resistance is for each of those patterns, and then plot out the moment resistance envelope, and again, making sure that your transitions occur over a development length. And as long as your moment envelope lies fully within that moment resistance curve, you've got something that works. Right? So that's kind of the next stage that we want to look at. So what we did in class in terms of figuring out what the moment resistance is and designing the beams is perfectly fine. This sort of process and what we were talking about last week with the slabs and coming up with that pattern of reinforcing and so on is actually more of a drafting exercise. Right? We've got some basic parameters that I want to work within, and now I want to just sort of tweak the spacing and the parameters a little bit in order to come up with a configuration that works and is reasonably efficient. It is possible to spend an awful lot of time going through this process to optimize rebar and minimize the amount of wastage and come up with a system that's reasonably economical. But of course, in most engineering budgets, we don't have that much money. So you're going to come up with a quick and dirty calculation, figure out your maximum moments, maybe do a little bit of reduction in areas where there's low moment, come up with a pattern that works, and once you've got something that works, you're happy with it. Right? We're not necessarily going to go, okay, well, I know my most optimal configuration is with row being about half of row balanced, so let's go back and redesign the beam, right? Come up with a different width and height, come up with a different strength of concrete. I mean, we could interpolate and iterate over and over and over to come up with an optimal configuration. And in most cases, we're just going to do one quick and dirty, get it right the first time. And so right meaning that it works, and then we move on and do the next part. Right, so that's about as much as I wanted to talk about in terms of design for this beams and slabs, and now we finished off our columns. The last thing that we want to talk about is going to be foundations. And we just have basically Monday's lecture, so not an awful lot of time to go through the foundations. I'm going to leave the rest of today for you to work on the Revit assignment, and we have all of the lab period next week to work on the Revit assignment as well. So hopefully that's enough time for everybody to get through it without too much problem. So next Monday's class, we'll do a little bit with foundations. We won't do too much. We'll just basically look at a pad footing. A strip footing is not a big extension off of a pad footing. It's basically just in one direction. So, and then we'll look at a little bit of review for the term as well. So that'll kind of wind down the rest of the course. So any questions on any of that before we break into Revit? Nope. Okay.